Okay, I wanted to do a short video on confidence intervals, and these are the sections that we're going to look at. We're going to do confidence intervals when the population standard deviation is known, when it's not known, and confidence intervals with population proportion. So, a confidence interval is an estimate around a mean, and it gives us a range. Okay, it's going to give us a range of values within which the true population mean is expected to lie. So it's an estimate around a sample mean, and it's going to give us a range within which the true population is expected to lie. A confidence level is defined as the probability that the interval estimate will include the population parameter. So as the confidence level increases, the probability of it lying within that interval will increase. So here are two assumptions, and this is something that will be asked on the homework. We're assuming, okay, the sample size is going to be greater than or equal to 30 and the population standard deviation is known. Remember from chapter 7, the standard error of the mean is the standard deviation divided by the square root of n, the population standard deviation divided by the square root of n. So the purpose of doing this is just to give an estimate for where the mean, about the population mean. So you're going to have an upper confidence limit and a lower confidence limit. And the limit is going to describe the range in which we have some degree of confidence, that's going to be our confidence level, that the actual population mean lies. So the confidence intervals is relating to the interval of the population mean. Okay, so here are our formulas to get the upper and the lower. You're going to take the sample mean, you're going to add for the upper and subtract for the lower. The z value associated with alpha divided by 2, and we'll talk about that, times the standard error of the mean. So here is an example where alpha is the significance level. It represents the probability that any given confidence interval will not contain the true population mean. So it's the probability that it will not. So here alpha is 0.10. So there's a 10% probability that the population mean will not fall between this confidence interval. Okay? So alpha divided by 10, let's look at that. So if we have a normal distribution, the interval is going to contain the probability of it being in that interval of 90%. So that 10%, we're going to divide it into 2. So part of it's going to be over here, 0.05, and part of it's going to be over here, 0.05. So you're taking the significance level and dividing it by 2, because under a normal distribution, it's symmetrical, so we're going to half it. Now, how did we get that z value? Well, think about it. If we want to get z here, the critical value, we would want to look at the probability all the way from that and back. So right here we have 0.90, and right here we have 0.05. So if we wanted to know the z-score all the way up to that, we would do 0.90 plus 0.05, and that would give us 0.95. So you can look up your critical value, which we talked about, 2 ways. You can look it up in the table. You're going to be working backwards though. So we'll talk about how you work backwards to find the z-score. Remember that norm inverse function? Okay, so the first step, we're going to find the standard error of the mean, which you're used to is the standard deviation divided by the square root of n. Okay, so find the z value, and it is 1.645, and we're going to talk about how to find that working backwards. Okay, so once you have the standard error of the mean and your z-score, those two numbers there, you're going to multiply those together and add it to your sample mean, and you're going to multiply those together and subtract it. So now we have our confidence interval, and based on our sample mean, which was 145.5, which is given to you, we are 90% confident that the population mean number of tickets sold is between 137.10 and 153.9. Now, when we multiply our z-score times our standard error of the mean, that is the margin of error. Okay, so that's another way to look at those two values being multiplied together. What is the margin of error? It's the width of the confidence interval. So when we did that, our margin of error was 1.645 times 5.105. And let me get my calculator and let's actually see what that value is. Okay, so you will get, your margin of error is going to be 8.398. Let's just round to 3 decimal places. So your margin of error. Okay, so our point estimate here was our sample mean, which was 145.5. So if we add the margin of error, we would get our upper limit, which is 153.9, and over here 137.10. So all the margin of error is, you're going to be asked to just calculate that. It's how wide your confidence interval is going to be for the upper and the lower. Okay, another important concept is what happens when we increase the sample size and keep the confidence level constant. So if you up the sample size, it's going to make the margin of error go down. So when you up the sample size, the margin of error is going to go down, and your confidence interval is going to be narrower and more precise. Why? Because when you increase the sample size, it's getting closer to the actual population. Okay. Here, it says we're 90% confident the true mean is between 137.10 and 153.9. The population mean may not be in this interval, but close to 90% of large number of sample means drawn from the population will produce confident intervals that include the population mean. So an incorrect interpretation, you have to be careful, is that there is 90% probability that the interval contains the population mean. This interval either does or does not contain the true mean. There is no probability for a single interval. We're just saying that close to 90% of a large number of sample means drawn from the population will produce this confidence interval. So be careful there. We can't guarantee that the population mean is going to fall within that. Okay, so here's some confidence intervals. All right, here's some, so here you can see, this helps you to see. For 90% confidence, 90% of intervals constructed will contain the mean. See these over here? But 10% do not. See this one over here? So all of these, the mean is fallen within our 90% interval. But this one over here is not. Okay, so the significance level represents any probability that the given confidence interval will not contain the true population mean. So the confidence level of an interval, let's say this is 0.10 or 10% is the not. So to get the confidence level, which is that it does fall, is going to be 0.90. So the confidence level and the significance level are going to add up to 100%. Okay, so I just remember these add up to 100%, and this does not contain, and this does contain. So that's a good way to remember that. All right, and if the confidence interval gets wider, if the confidence level increases, like it goes from 90% to 95%, the confidence interval is going to get wider. Okay, so look at a 95% confidence level. Okay, so here's our 95%. This is our confidence level. And then the significance level is 5%. Because we have 2 tails, so 5 divided by 2. The z value associated with this, well, if you want to calculate the z, you've got to get the probability from that point all the way back. So you're going to have to add the 95% plus the 2.5%. So that would be 97.5% or 0.975. So if you went to your table, you would look in the table. Let me show you what I mean real quick. Okay, this is table 4 in the appendix. So I'm looking in the table. It's kind of like a reverse phone lookup. You know, when you do the reverse phone number lookup. So I'm looking, it's kind of like I have the phone number and I need the name. Well, here I have the probability. I need the z-score. So if you look in this table, 0.975 is right here. So that is 1.9, and if you go up, 1.90, 1, 2, 3, 4, 5, 6. So 1.96. That's where that number came from. Also, if you put it in Excel, let me show you that. So you put in 0.975 for the norm.s.inverse, and it will give you the z value 1.96 if you round to 2 decimal places. So that's how you can get your z-score. Or here's a table for the main ones that are used that you can use. Here is a way to calculate the margin of error in Excel. We're going to be doing that as well. Okay, so when the standard deviation is known, and when the sample size is less than 30, and we know the standard deviation, the population must be normally distributed. So we're going to assume that the population is normally distributed, okay? With n being less than 30, the central limit theorem cannot be applied. So we can't really say the sampling distribution will be approximately normal, but the sampling distribution is always normal if the population is normally distributed. All right, so I just wanted to kind of introduce that to you, and that is mainly what section 8.2 is about. I know this was a longer video, but it was a lot of little things I had to cover. Please let me know if you have any questions.